Hi guys, and welcome to this video. This is based on the pH calculations that I would have given you for homework last Thursday. So in most of these questions, guys, there was a few tricky things. Either you had to convert from grams to moles, centimetres cubed up to a litre, or you had to use the Ka concentration for weak acids or bases. And to be honest, the first question has absolutely everything jam-packed into it. So I'm starting off with 0.3 grams of our ethanoic acid, CH3COOH. That's in 50 centimetres cubed of water, and we need to get that to moles per litre. So I'm just going to start by going from grams to moles. Now, rough work. I need to do this. I need to divide by my relative molecular mass. So my relative molecular mass of ethanoic acid is 60. Carbon is 12, hydrogen is 1, but I have 3, oxygen is 16, and I have 2, and we have our final hydrogen down here. Adding all of that all up, you get 60. And when you divide your 0.3 by 60, guys, you get 5 by 10 to the minus 3 moles. But it's really important to remember that that moles is in 50 centimetres cubed. To get it to a litre, we divide it by what it's in, which is 50. We multiply it by what we want, which is a litre or 1,000. When I do all of that, we get 0.1. We can then use this figure and we add it into our H plus ion concentration formula. So our formula for this, and start over here, is equal to the square root of your concentration multiplied by your Ka. In this instance, our concentration is 0.1. Our Ka is given to us in the question, and that's 1.8 by 10 to the minus 5. So we get a value of our H plus ion concentration to be 1.3416 by 10 to the minus 3. Now, I would always include a few extra decimal points in the H plus ion concentration and not write down until I pop it into the pH formula. Final step. pH is equal to minus log base 10 of this H plus ion concentration. So I'm going to put that into this formula down here. 1.3416 by 10 to the minus 3. And doing that, I get an answer, guys, of 2.87. So our next question, guys, again, we're looking that our pH, we have moles given to us, but unfortunately the moles are given to us in 100 centimetres cubed. So the first thing I'm going to do is bring that 5 by 10 to the minus 2 in 100 centimetres cubed. I want to bring that to 1 litre because we need moles per litre. So I multiply by 10. And when I do that, I get 0.5 moles in 1 litre. So then we can start to calculate my H plus ion concentration. So don't forget, H plus ion concentration is equal to my concentration or my molarity multiplied by my Ka. In this instance, that's 0.5 multiplied by 5.5 by 10 to the minus 5. Sorry, I'm going to run out of space. When we do all of that and we get our square root of our answer, we get 5.244 by 10 to the minus 5. We then take this figure and we put it into our pH formula. So pH is equal to minus log to the base 10 of 5.244 by 10 to the minus 5. And doing all of that, I get an answer of 2.28. Guys, there's two questions here. The first one I'm looking at is which is the stronger acid. So to identify the stronger acids, if you've just been given the value for Ka, you always look for the biggest number. So in this instance, our methanoic acid number is bigger than our value for ethanoic acid. So in this instance, our methanoic acid is a stronger acid, and that all our dissociation constant means is that it dissociates more into its ions. Remember, an acid is a proton donor. It's dissociating more, so it's giving more protons, and that's why it's a stronger one. Next one down, so we're looking to calculate the H plus ions in a 0.1 molar solution of ethanoic acid given Ka is equal to this. And this is nice and easy, guys. H plus ion equal to our concentration, which is 0.1, multiplied by my Ka, which is 1.8, by 10 to the minus 5, and we should get an answer of 1.34 by 10 to the minus 3. Okay, final question. Again, this is kind of split up into two parts, but we'll have a look. So we're going to break it up into two questions. So calculate the hydrogen ion concentration and show the approximate value of the dissociation constant is that. Now, we've been given the value for pH. So if I was to write down my formula for pH, it would be pH is equal to minus log base 10 H plus ion concentration. This time around, I know my answer for pH. pH is equal to, so in this example, our pH is equal to 2.37. I'm given that in the question. So we rewrite it as 2.37 is equal to minus log to the base 10 over H plus ion concentration. Okay, so we're working backwards in this instance. To do this, there's a few steps that we have to do. The first thing I'm going to do is I'm going to bring my minus sign across the equals. So my next line reads minus 2.37 is equal to log base 10 H plus ion concentration. The next thing we do is we take the anti-log of both sides. Now to take the anti-log, on your calculator you pressed second function or shift and then press your log button, and when you do that you should see a 10 with a little box appear from it. So into our calculator the number 10 should appear and a little box, and into the little box we put minus 2.37, so don't forget to carry the minus sign down with you, and that's equal to our H plus ion concentration. When you calculate that, I get a value of 4.266 by 10 to the minus 3. Now in this question there's another part. They want to show you to show the approximate value of the dissociation constant is 1.8 by 10 to the minus 5. So to do that, we need to show that that's approximately equal to our answer in the previous question. Now the key word in all of this is approximately. So if some of the decimals are different, that's okay. So we want to show that the H plus ion from the previous question is roughly similar to the H plus ion concentration in this one. So H plus ion is equal to the square root of our concentration, which is 1, times our dissociation constant, which is 1.8 by 10 to the minus 5. And when I put that in, guys, I get 4.2426 by 10 to the minus 3. Okay, so in our previous answer, we got a H plus value to be 4. So do it in a different colour, 4.266 by 10 to the minus 3. So I know our decimal points are slightly different, but again, we want to see the approximate value. Final question then, guys, is asking you to calculate the approximate value of pH of a 0.05 molar solution of ethanoic acid. So we're going to use our value for Ka from the previous question. So to calculate our H plus ion concentration, we use our formula square root of our conc, which needs to be moles per litre, multiplied by our Ka. So our concentration is given to us in the question. It's in moles per litre because it's given to us in a capital M, moles per litre. Multiplied by my Ka. I worked out Ka in the last part of the question, so it's 1.8 by 10 to the minus 5. And when I do all of that, guys, I got 9.4868 by 10 to the minus 4. Like I said, I would always give a few extra decimals, especially when I know I'm going to be carrying it on to the minus log formula. Final part then, to calculate the pH, I put this number into the minus log formula. So 9.4868 by 10 to the minus 4. Doing all of that, I got an answer of 3.02. Don't forget pH and the minus log formula is for both higher and ordinary levels. What I've just been doing there in terms of the weak acids and weak bases, that is a higher level material only. If you have any problems with any of these, feel free to send me a message on Skillology. Hope you're all well. Thanks.